Still focusing very much on climate change, so the historic and future modeling and mapping of early season temperature patterns and extremes and impacts for pome and stone fruit production. So a very quick background. I think I've already said many of the things that relate to this. Growers are experiencing erratic and extreme weather conditions from dormancy until fruit set and early fruit growth, and this is possibly linked to climate change. So the aim of the study was to investigate early season temperature patterns during the historical and projected future periods and their impacts on pome and stone fruit production. For the modeling and mapping, we used two time frames, the historical time frame, 1961 to 1990, and the immediate future time frame, 2016 to 2045. And we also calculated and mapped the differences or the changes between the future and the historical periods. For the climate change modeling, we used 6 different general circulation models that are currently used in South Africa, and we used a scenario, a climate change scenario called RCP 8.5, which is basically a business as usual emissions scenario. For the spatial focus, we looked at 7 broader groups of production regions: southwestern coastal, northwestern cooler, northwestern warmer, Langkloof, Little Karoo, Berg River Valley and Stellenbosch, and Breda River Valley. We used 4 generic fruit types for the modeling. We used ultra early, early, mid, and late generic fruit types, and the dates that are visible on this table. For this particular presentation for pome fruit, I'm only going to focus on mid and late. And for each period, so the first period from dormancy until bud swell, we modeled 3 different chill models and also days above 18 degrees, so heat. For the bud swell until full bloom period, we modeled growing degree hours, hot conditions during pollination period, low temperatures during pollination, frost days, and variation of temperature in that period. And for the full bloom until fruit set period, we modeled growing degree hours. All right, for the mid-fruit results, now this would be the early flowering pears, and it's across all the production regions. What we found that under climate change in the future, we could find more extreme desiccating weather. In other words, heat combined with low relative humidity and often wind in the pollination and the fruit set period. This could lead to losses in quality and production, and more pest pressure in some cases as well. The early flowering pear cultivars, for example, Forel, that are susceptible to cold weather and frost in the flowering and fruit set period, especially if this is preceded by a warm spell and earlier bud break. With future warming, these early pears could actually have a reduced risk and benefit from climate change, provided that extreme heat is not experienced in this period. In the warmer production areas and for cultivars such as Packham's Triumph, the results show that these may do less well under future warmer conditions in certain areas. Specifically as well, in terms of shifting flowering periods, we find that between the different pear cultivars, as the flowering periods shift, we might have to make sure that, or growers will have to ensure a sufficient cross-pollination for pears. If we look at the results for apples, what comes out strongly is the loss of chilling, the weaker flower synchronization and extended flowering, growth habit changes, and then of course shifting flowering periods and cross-pollination and extreme hot and dry weather in the flowering period, as similarly to the previous ones. Increased sunburn, because this is now later in the season, we're starting to go into hot temperatures and pest disease pressures. And then also where warming leads to earlier harvest dates, this can lead to fruit size and storability challenges and also logistics. All right, I've got 1 minute left. Let me quickly go to the conclusions. So the high diversity of climates across all the production areas in the Cape is a feature, and numerous microclimates, and these interact with fruit types and their climatic requirements. So we might find that in some areas there's relative stability and contraction into some core areas. We may need some adaptation there, but those are core areas. We may find loss of stability in other areas and a need for substantive adaptation in those areas. There will be opportunities for expansion into new areas, but rather microsites rather than larger areas. And we may lose some of the outer marginal production areas. In terms of the highest risk, we found that the warmest parts of the EGVV is certainly at risk around Verliesdorp and also around Greyton and parts of the Breda River Valley for pears. Adaptation strategies are numerous, and I'm just highlighting one of the most important ones here: strong cultivar development program and site-specific cultivar and rootstock selection are going to be very important. Thank you to Hortgrove as a funder, and I also want to thank the Project Reference Group members for their time, interest, and inputs. And of course, my collaborators, Nick Davis and Roland Schulze. Thanks to them as well.